Hello everyone, it's Ms. Thomas, and today we are looking at transforming absolute value functions. So as we discussed in class, the parent function for absolute values is the y equals absolute value of x, so that's the graph at its most basic form. With this parent function, the vertex of the v is at the point 0, 0. The axis of symmetry is at x equals 0. And as a reminder, the axis of symmetry is just a line that cuts a graph into two symmetric pieces. So it's a y-axis in this one. And as we discussed in class also, this is really just the equation of a line and its reflection centered around that vertex. And the slope on this is a slope of 1 and a slope of -1. So transformations to this parent function occur following the rule of y equals a times quantity x minus h plus k. hk is the coordinate of the vertex. It's a shift of h unit horizontal shift. Keeping in mind this minus h and this is a positive h, we always do the opposite of what's in that absolute value sign for the value of h. But we do preserve the sign on the k. A leads to a stretch or compression. It is a stretch when A is greater than 1 and a compression when A is between 0 and 1. And when we're talking about the A, we're really worrying about its actual absolute value. It's a little bit confusing when you're talking about absolute value of A in terms of the absolute value equation, but we're really just talking about, is it 2, is it 0.5, is it 1.5, without worrying about its sign. But when A is negative, is a reflection. So what is the graph of 1/2 absolute value of x? So if we want to think about graphing this without making a table of values, you do want to consider your h and k. So since there's nothing added or subtracted, I know that my vertex is going to still be at 0, 0, even though I have this 1/2. The 1/2 is the value, the absolute value of my A, and it's going to be a vertical compression. And we'll see what that looks like. It's a compression on the output values. But since it's the absolute value should be pretty easy. The A is going to work like a slope. So if normally I would have my first point at 1, 1 on the parent function, I'm just going to use the slope of 1/2, 1, 1, 2, and there's my first point. up 1 over 2. There's my second point. And I would go over and back as well, because it should be symmetrical. There's one ugly line. So you can see that a vertical compression really is almost like it's the rate of the lines increasing is decrease. So it's going to take longer for it to reach the same y values as it did on the parent function. What is the graph of -2, absolute value of x, plus 1, plus 3? So my vertex is going to be at -1, 3, because I always do opposite of h, and then just my k. And then the 2 means it's going to be a stretch. And the negative means it's going to be flipped. So, first plot your vertex, -1, 3. And then I basically have a slope of a -2. So from here, I'm going to go down 1, 2, over 1, 1, 2, over 1, 1, 2, over 1. So that's half of my graph. And then I need that to be reflected. So I go down to left 1, down to left 1, and that is my graph. So without graphing, we want to describe how the parent function is transformed by y equals 3 times the quantity x minus 10 plus 1. So this is kind of what we've been doing. So it's going to be a shift of 10 units to the right. A vertical shift one unit up because of this, and a vertical stretch by a factor of 3. So now it's time for you to try. You need to graph y equals 3/2 times the quantity x times the absolute value of x minus 6.